Hi everybody. Today we're going to talk about confidence intervals, and they're a little bit different from what we have been doing. So right now we've been getting things like X bar, which is a point estimate, and S, again, it's a point estimate. So we get one value at a time. So what we're going to be doing now is getting things like, say, 500 less than mean mu less than 600. Okay, so we're going to figure out how to do those. So that way we can say, well, we think our mean is going to be between these two values. And this is very good because it gives us a range of values for things to fall into. But we have a particular way of doing this, and this is what we're going to discuss. Okay, so the first thing we need to do is look at our friend, the standard normal. This is the one that has the 0 in the center. And we will ask typically for some kind of 1 minus mu times 100% confidence interval for mu. There are confidence intervals for all kind of concepts, but we're just going to be looking for the ones for mu. So what that means is you're going to cut off 1 minus mu. That's the shaded in part. Okay? So, and again, we think about how the normal curve is constructed. If 1 minus mu is shaded in, sorry, my fault. 1 minus alpha is shaded in, then alpha is left over. But we know that the normal curve is symmetric, so we have alpha over 2 and the unshaded piece to the right, and alpha over 2 in the unshaded piece to the left. So what we want to do is find these values where the x's are, and that's going to help us construct our confidence intervals. But because of symmetry, so this is going to be z here and minus z here, because of symmetry, these values are identical except for sign. Yay! So let's test one out. Suppose I want to have a 95% confidence interval. So I'm going to shade in 95% of the curve. And I have 5% left over on each side. So that means I have 0.025 here, and I have 0.025 here. Because I took 1 minus 0.95, and I got 0.05, yes? And then 0.025 over, my fault, 0.05 over 2 gives me 0.025. Okay. So that being said, I'm going to take 1 minus 0.025, and that's going to give me 0.975. And that's how much probability there is from here all the way up there. So I'm going to use my normal curve in reverse and look in the middle for 0.975. And when I do that, I'll pick up 1.9 from the left and 0.6 from the top. So Z is going to be 1.96. And then, of course, on the left-hand side, it'll be minus 1.96. Okay? Pretty good? Good. Let's try another one. Let's see. What should we try next? How about a 90% confidence interval? And again, we're just doing the z part. There's more to it than this. Okay? So, I'm going to take 1 minus 0.90, and that gives me 0.10. Alright? I'll take 0.10 over 2, and that gives me 0.05. So that's how much is in each of those tails. Then I take 1 minus 0.05, and that gives me 0.95. And the closest hit, this is one of those funny ones, it's at a halfway point, but we're going to use 1.64, or if you prefer, if you want to interpolate, you can use 1.645. Okay? And eventually you will see, we're going to set up a formula, x bar plus or minus z times sigma over the square root of n. So what we have just done is found the z component. Alright? Hope this helps.